Namaste, Namaste JVWU. I JV'N Gaurav from the Faculty of Disscipation and Diagnostics in the Department of Diagnostic and Community Health in the discipline Radiology from JV'N University. Today we are discussing a session that is important or useful session for application of radiation imaging technique or radiographic technique and general radiation physics. So today's session will be helpful for the student to know or understand the general radiation physics or production of X-rays or any type of particles or rays or the positioning of patient. Okay. Namaste. In today's session, we will discuss about the heat dissipation method that is required to dissipate or removal of heat from the anode or target. There is a session from general radiation physics section for BScRT II student. What is the heat dissipation? Why it is required? Heat dissipation means the removal of the heat, extra heat from the anode that is deposited by the electrons by interacting the anode. Okay. So heat removal is required for to avoid the melting of the target, avoid the evaporation of the target, or long operation of the target or X-ray longevity of the X-ray. What is heat dissipation? Heat dissipation is a heat removal because when electrons interact with the high kinetic energy electrons interact with the target, greater than 99% electrons is converted into the heat. Only less than 1% electrons converted into the useful activity. So heat dissipation is must or it is required the most. The first method, target are made by inserting a layer of tungsten in the copper block, which removes the heat from the tungsten very quickly. Second is the X-ray tubes are usually enclosed in a metal case which are filled with oil for insulating purpose. Okay, for insulation means it is filled by the oil that provide a oil convection that removes the heat from the glass tube to metal case. Okay, the oil convection transfer the heat from the copper block to metal case. Okay, or there is a air convection means the flow of air is also given, also provided, so it transfer the heat from the metal case to surrounding. Okay, thank you. The session is over. Namaste. In today's session, we will discuss about the grid control X-ray tube in general radiation physics for BScRT second sem students. So what is grid control X-ray tube? X-ray tubes usually contain two electrodes. The switches used to on or off exposures must be able to withstand large changes in applied voltage. A grid control X-ray tube contains its own switch which allows the X-ray tube to be made on or off rapidly. So grid control X-ray tube contains the switches that is used to off or on the X-ray tube rapidly. A grid-controlled X-ray tube contains three electrodes. The anode and cathode forms two electrodes, and the third electrode controls the flow of electrons from the filament to the target. Usually, the focusing cup acts as a third electrode. So, the grid-controlled X-ray tube contains three electrodes, anode and cathode. These are forms two electrodes, and the third electrode control the flow of electrons from the filament, from the cathode filament to the target anode. Usually the focusing cup acts as a third electrode called grid. The grid is electrically negative relative to the filament. The voltage across the filament grid produce an electrical field along the path of electron beam. Means grid is electrically negative related to filament. ओके, जैसे फिलामेंट नेगेटिव है, ऐसे ये अपन कह सकते हैं कि ये जो ग्रिड होती है वो भी नेगेटिव है. द वोल्टेज अक्रॉस द फिलामेंट ग्रिड प्रोड्यूसेस एन इलेक्ट्रिकल फील्ड along the path of the electron beam. Okay, it produces the electric field or the pushes electric field that pushes the electron even closer together. Okay, that pushes the electron closer to one another or together. If the voltage is made large enough, the tube current may be completely pinched off and no electron go from the filament to the target. Means here we are talking about the saturation potential. So if the voltage made large enough, the tube current may be completely pinched off, means tube current is maximum and no electron go from the filament to target. Above the saturation potential, there is no electron that go from the filament to target. The voltage applied between the focusing cup and the filament are close together. Between the focusing cup filament are close together means the value of the voltage is close of the filament and the focusing cup. The voltage necessary to cut off the tube current is not very large. The voltage that is used to cut off the current is not a very large potential. Okay, so in this view, in this session, we have discussed about the grid control X-ray tube. Grid is the third electrode that is used as a focusing cup, or it produces the electric field, or it is a negative related to the filament. Okay, thank you. This session is over. Namaste. In today's session, we will discuss about the speed of the anode rotation in rotating anode X-ray tube. That is a part or session of general radiation physics setting for BScRT second sem students. So the speed of the anode rotation. Let's discuss. The anode is made in the form of large disk of tungsten. Okay, anode is made of the form of large disk of tungsten or an alloy of tungsten. Okay, which rotates at a speed of about 3,000 revolutions per minute. Okay, this will facilitate the electron to bombard a constantly changing area of the target. Means if there is no rotation, the area where the electrons bombard is fixed or same. But when it is rotating 3,000 revolutions per minute, then it is constantly changing the area of the target where the electron bombards. So the tungsten disk has a beveled edge. Beveled edges. The angle of bevel may vary from the 6 to 20 degrees. The bevel is used to achieve the line focus principle. लाइन फोकस प्रिंसिपल विवेल ये होती विवेल होंगे इसी की तरह. The disc is mounted on the stem and the stem is attached with a copper cylinder called rotor. So disc is mounted on a stem, disc, disc or anode assembly, anode target is mounted on a stem, and the stem is attached to the copper cylinder called the rotor that rotates motor, that rotates by motor. The anode assembly rotates with the help of bearing. Anode assembly rotated with the help of bearing. The stem is made of molybdenum, which is having high melting point. So melting point of the molybdenum is high, and poor heat conduction or conduction of the heat is poor in case of molybdenum. The molybdenum stem prevents the flow of heat. Molybdenum stem prevents the flow of heat from the tungsten to the bearing of anode assembly. Okay, so the molybdenum stem prevents the flow of heat from the tungsten to the bearing of anode assembly. So it prevents the heat flow backward from the tungsten target to tungsten disc to bearing. Okay, so this session is over. I think you all will get a good knowledge or a knowledge about the rotating anode accelerator or speed of the anode rotation. Thank you. Namaste. In today's session, we will discuss about cathode assembly. Cathode assembly in that is important component in the accelerator tube. That is a session of general radiation physics second for BScRT citizen students. Cathode assembly. So let me discuss about the cathode assembly. Rotating anode accelerator tube. Rotating anode accelerator tube consists of a cathode and anode, which are kept in a glass bulb or glass envelope. Okay, so the rotating anode accelerator tube having two different charge, different potential electrodes. It's called cathode and anode, or that is kept in a glass bulb or envelope. The cathode is a tungsten filament which is offset from the long axis of the accelerator tube is to face the target near the periphery of the anode disc. To face the target near the periphery of the anode disc. Face the target. Usually rotating anode tubes are fitted with two filaments. One is larger than the other. Placed side by side in the cathode assembly. One filament is designed to focus the electrons on a larger area of anode. Okay, so one filament is designed to focus the electrons in a large area of the anode, which requires heavy tube loading. So it requires heavy tube loading. The other filament is used to focus the electrons on a smaller area of target. This type is used when high resolution is required. It is for resolution. The first one is four line focus principle. Second one is the for resolution, for getting high resolution and image. This type is used when high resolution is required. Both filaments should focus the electron on the same part of the anode. So the focal spot is at the same point for both the modes of operation. Some tubes provide two target angles or two filaments, so that each filament will have a separate focal spot. Smaller angle is used strain the smaller focal spot. Okay. So then simply, cathode is a negative charge electrode or negative potential at a negative electrode that is in negative potential. It has a filament that is in the form of wire or spiral. Okay, in rotating or stationary anode active force. The filament is made up of tungsten material. It works on the thermionic emission principle. When high voltage is applied by the source, electricity source, high voltage is applied on the filament emits electrons that having a high kinetic energy, and after that the electrons strike to the target, and the flow of electrons from the cathode to anode is controlled by focusing cup. Focusing cup focuses the electron from the cathode to anode. Okay, this is a negative potential electrode. Anode or target is a positive potential electrode. Okay, so cathode assembly having the filament, it has a focusing cup that is both the filament and focusing cup is at same potential in some cases, same potential in most cases. Okay, so thank you. The session is over. I think it will help to understand. I think you will get a good knowledge after watching the video. Okay, thank you. Thank you. The session is over. I think you are satisfied with this session. If you have any query, then put it into the comment box. I will resolve it later. Thank you. This session is over. The session is powered by digital version 2.0, JV'N Namaste JVWU.